Section 3.2, the chain rule and the general power rule. In this section, we will use the chain rule to find the derivative of a function. Use the general power rule to find the derivative of a function. As you recall the power rule, as y equals x to the power n, so the y prime is n x to the power n minus 1. And also, we will apply several rules in combination to find the derivative of a complex function. The chain rule: if y equals f of u and u is e of x, then the derivative dy by dx is the product of dy by du and du by dx, provided the dy by du and du by dx both exist. Example 1, using the chain rule, suppose that y equals u plus square root of u and u equals x to the third plus 17. Use the chain rule to find the derivative dy by dx, then evaluate dy by dx at x equals 2, which is the same as the notation dy by dx with the line or the bar on the back with the lower the subscript x equals 2 to indicate that the derivative will be evaluated at x equals 2. Using the chain rule to find the derivative, then we have y in terms of u and u in terms of x. So dy by dx will be the product of dy by du and du by dx. Okay. Our y is u plus square root u, which is u plus u to the power 1/2. So the dy by du would be 1 plus 1/2 u to the power negative 1/2. Or we can write the negative power as a positive power. So then dy by du is also in the form of 1 plus 1 over 2 square root of u. As u equals x to the third plus 17, we get du dx as 3x to the second. Back to the formula of the chain rule. Since dy by dx is dy by du multiplied by du by dx, we obtain dy by du as 1 plus 1 over 2 times square root u, and du by dx is 3x squared. And also u is x to the third plus 17. We write or replace the u with the term x to the third plus 17 and then multiply by 3x squared. So this is the derivative of the y with respect to x. Next, we are going to evaluate this derivative at x equals 2. Replace x with the value 2. We obtain 1 plus 1 over 2 square root of 2 to the third plus 17 multiplied by 3 times 2 to the second. For 2 to the third plus 17 is 8 plus 17 or square root of 25. Square root 25 is 5. 5 times 2, that's 10. So we have 1 plus 1 over 10 multiplied by 3 times 4, which is 12. Simplify the numbers. So we get 11 over 10 multiplied by 12. And simplify further to get reduce. This is 5 and this is 6. So becomes 66 over 5 as the final result. Another form of the chain rule, as y in the form of the composite function f composed with a gx. F is the outer function and g is the inner function. Then the derivative dy by dx is the derivative of the outer function multiplied by the derivative of the inner function. Provided f prime at gx and g prime at x both exist. Use the second form of the chain rule to find dy by dx if y equals the quantity x squared plus 3x minus 7 raised to the power 5 over 2. In this case, we have the power 5 over 2 as the power of the entire quantity. So this one can be rewritten as f of gx, where g is the inner function, or the quantity gx raised to the power 5 over 2, which tells you the f of the function gx is the function raised to the power 5 over 2. Then to find dy by dx, which is the derivative of the outer function multiplied by the derivative of the inner function. The outer function has the input as a function g. So we're gonna replace the gx as the input of the f prime. So the derivative of the outer function, which is the power 5 over 2, will be 5 over 2 multiplied by the inner function, which is gx, raised to the power 5 over 2 minus 1, and then multiplied by the derivative of the g. Since the gx is x squared plus 3x minus 7, the g prime of x would be 2x plus 3. Then we multiply this by 2x plus 3 and replace the gx for the first group here by 2x plus 3. 5 over 2 quantity 2x, 2x plus 3 raised to the power 5 over 2 minus 1, which is 3 over 2, and multiply by, sorry. This is the wrong one. So the g is x squared plus 3x minus 7 raised to the power 3 over 2, and the g prime is 2x plus 3. This example determine h prime at 5 if h of x is the quantity 25 minus 2x plus x squared to the power 3, another composite function form. If you write it as the composite function of f and g, f is the outer function and g is the inner function. In this case, your gx is 25 minus 2x plus x squared. That tells you the g prime at x would be negative 2 plus 2x. And the function f would be the function of the quantity raised to the power 3. So the h prime of any x would be the derivative of the f, which is the outer function, and then multiply by the derivative of the inner function g. And the input of the outer function is the function gx. We just fill it in. The f, which is the quantity to the power 3, the derivative will be 3 of that quantity to the power second. And that quantity is the quantity of the gx, which is 25 minus 2x plus x to the second. And then the derivative of the g, which is -2 plus 2x. You can simplify a little bit more by factoring 2 out from the g prime of x. You get 2 times -1 plus x. And then the derivative of the h would be 6 multiplied by 25 minus 2x plus x to the second all to the power 2 multiplied by -1 plus x. And next, we're going to find h prime at 5 by substituting the x by 5. From h prime equals 6 multiplied by 25 minus 2x plus x squared raised to the power second multiplied by -1 plus x. Replace x with 5. That's 6 multiplied by 25 minus 2 times 5 plus 5 to the second raised to the power second multiplied by -1 plus 5. Simplify the numbers. -1 plus 5, that gives you 4. 25 minus 10, which is 10, 15. 15 plus 25, which is 40. So 6 multiplied by 40 raised to the second power and multiplied by 4. The final result, we write it in the better form. So 6 multiplied by 40 squared and then multiplied by 4. The final result, or h prime at 5, will be 38,400.